As we know, the ChatGPT is a chat assistant. You ask, it answers in text, and it stays in a sandbox without access to your machine or tools. OpenClaw is an agent that runs on your computer. It uses chat such as Telegram, Discord, WhatsApp as an interface, but executes real actions, printing, running scripts, accessing files through skills with memory and optional proactive behavior, such as heartbeats. So what is OpenClaw? So OpenClaw is a self-hosted gateway that connects your favorite chat applications, WhatsApp, Telegram, Discord, and more, to AI coding agents. You run a single gateway process on your own machine or a server, and it becomes the bridge between your messaging application and always available AI assistant. So what it's for? Developers and power users who want a personal AI assistant, they can message from anywhere without giving up control of their data or relying on a hosted services. What makes it different? Self-hosted, it runs on your hardware, your rules. Multi-channel, one gateway source, WhatsApp, Telegram, Discord, and more simultaneously, etc. So our application is an OpenClaw skill that lets you print from anywhere over Telegram. You type command like print text, such as print hello world, in a chat, and the text is sent to your printer at home. It runs on your computer, checks that you are allowed to use it, turns the text into PDF, and prints it using your default printer, which may be connected via Wi-Fi. Telegram is the messaging application where you chat, and BotFather is the official Telegram bot that creates new bots and gives you their API token so your application can receive and send messages. So open Telegram and search for BotFather, like I like I already did. Start chat with BotFather and send the command new bot. So now enter a username for the bot, which must end in bot, such as my printer bot that I already did. After that, you will receive bot token, something like this, a message like congratulations on your new bot and the token to access the HTTP API. Store this token securely. It's your bot's API key. OpenClaw or your application will use it to listen for messages and control the bot. You then configure OpenClaw to use this token so it can handle messages sent to your bot. If someone knows your bot token, they can control your bot, read and send messages, act as the bot, and even misuse it or trigger unwanted behavior. Treat the token like password, store it in environment file, never commit to GitHub, and if it's exposed, revoke it using /revoke command and create a new bot. When you create a bot, you will receive your Telegram user ID, which identifies your account to the bot. We will add it to our Telegram authorized user so the print skill knows it's allowed to print for you. And you will see the pairing code. It connects your Telegram account to OpenClaw or the gateway. You enter or send this code so the application can link your account and receive your messages. Without pairing, the application doesn't know how to access commands from you, how to accept commands from you. In short, your Telegram user ID tells the print skill who is allowed to print, and printing code and pairing code connect your Telegram account to OpenClaw so it can receive your messages, which you will see in action later. Easiest way to install OpenClaw on Windows is using npm. So npm install -j OpenClaw latest. It installs it globally. You can check the installed version with OpenClaw -v command. In my case, it's 2.19 version. OpenClaw requires Node.js runtime version that is greater or equal to 22. So OpenClaw has been tested on version 22. Initially, I installed Node.js version 23, but I faced an agent communication issue where it hung. Downgrading to version 22 resolved this. But Node.js 22.0 will not work for the next command, the OpenClaw onboard. You need at least Node.js version 22.12.0 version. So we can check it. After installing the correct Node.js version, we run OpenClaw onboard install-daemon command. Yes. QuickStart, yes. Since I already installed OpenClaw, the configuration handling will appear. Most of it reflects a fresh installation, so I'll select use existing values. Select provider. I chose OpenAI, then OpenAI key option. So in my case, I already have key set in my environment file, so I confirm with yes. I select GPT 4.1 mini. Next, select the token we discussed. I skip this step since I already entered it. Configure skills, yes. You will see some predefined skills. We will not use them. Instead, we will use a custom skill. So we press paste, then enter. So no, 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 no. Yes, we will not use hooks. So enter, skip for now. So the onboarding process installs the gateway service. Since I already have it installed, I click restart. I will now closing the shell. We will start it via the command line later. On native Windows PowerShell, OpenClaw onboard install daemon doesn't work. The daemon setup assumes Linux style service manager. On native Windows, daemon installation is not supported. You can use WSL2 for daemon support or run OpenClaw manually without the daemon. OpenClaw will not appear in Windows services on native Windows. Open a PowerShell and run OpenClaw pairing Telegram your pairing code. It should be approved Telegram. I already ran this command and received a successful message. So parent links a Telegram account to your OpenClaw setup so that the person is authorized to use your bot. Treat the parent code as somewhat sensitive, don't broadcast it. It's not as critical as the bot token because approving a code requires access to your OpenClaw CLI. After the OpenClaw installation, you will see the OpenClaw's user data directory. So OpenClaw JSON, it's a main config, including channels, agents, gateway. We will discuss it. Workspace. So it's your workspace that includes agents, MD, skills, memory, credentials. It's Telegram, pairing, allow lists, etc. Devices. It's paired devices. It's paired JSON, pending JSON, agents. We will look into it. Identity. Device identity and authentication. It's logs, log files, and the Chrome. It's cron jobs. So let's walk through the OpenClaw JSON configuration file. It's meta, it's the last edit time and OpenClaw version. Wizard, it's onboarding state, last run, command, mode, auth. It's authentication profiles for Google API. Agents. So as we selected the default model, it's GPT 4.1 mini, workspace path, wordbit, currency. It's a messages, it's reaction scope, it's a details over on, commands, native skills, restart behavior, who can run commands, hooks, allowed agent IDs for hooks, it's channels, it's a telegram, so enable pairing, bot token, group policy, stream mode, and gateway on the port, the local mode, authentication token, commands, camera, credentials, calendars, etc. We will look into it. And plugins, enabled plugins. In this case, it's Telegram. Let's run OpenClaw gateway. Run verbose command. When the dashboard opens, you may not be able to connect at first because it requires a gateway token. To get the token, we run OpenClaw config get gateway out token. So keep this token private. It's used to authenticate clients with the gateway. Only clients that know this token are treated as trusted and are allowed to use the gateway. Once you get the token, copy it and paste it into the gateway token field and then click connect. We are going to connect through Telegram, but I'm showing this dashboard step just to you to understand how it works. So the sessions, active chats and conversations, the channels, status of Telegram, Discord, etc. Skills. Skills run the same way in the dashboard as on the channels. The agent decides when to call them based on your message and its rules. And configuration. In short, it's a web view for viewing and managing your OpenClaw agent and its channels. One thing I want you to notice is that on the skills, we have some built-in skills that we didn't choose during installation. However, under the workspace, we have a Telegram HP print skill, which we'll be discussing soon. This is our custom skill. So in addition to skills, there is also chat area for interacting with the bot. So I type hello, how are you? And receive a response. When you chat in the dashboard, you are talking to the same OpenClaw agent that handles Telegram, Discord, etc. So you send a message in the dashboard, the gateway passes to the agent. The agent uses the same tools, skills, and rules like AGENTS.md workspace that we will come to the AGENTS.md soon. And the reply appears in the dashboard. So you can test the agent without using Telegram or Discord. You can see tool calls and behavior in one place and debug and inspect conversations easily. So chatting in the dashboard is like chatting with your OpenClaw agent directly in the web UI. So user sessions are stored in agents main sessions folder. If I delete the session from the folder, it will no longer appear in the chat area. In OpenClaw JSON, the agent's default workspace path is the HP OpenClaw workspace, which is the root folder for our agent. Skills live on the workspace skills folder. Skills are reusable actions the agent can run when it matches a trigger. If we navigate to that folder, we will see Telegram HP print folder, which contains our Node.js application inside, and inside we have skills.md file. Skill.md is the skills manifest that tells OpenClaw what it does when it runs, what it's allowed to do. It acts as the contract between the skill and the agent. Without it, the agent wouldn't know how to invoke or use the skill. So name is skill ID, like Telegram HP print, used in logs and references. Description, short summary of what the skill does. Runtime, execution environment. Entry, its script run when the skill is triggered. And permissions, triggers, its phrases that activates the skill. For example, print. The agent matches this in our messages. And permissions, when the agent is allowed, what the agent is allowed to use, like shell execution to run commands or Telegram send message to send Telegram messages. When run CLI.js is called, two arguments are passed, which we will see soon. First is chat ID, it's your Telegram user ID, which we have already seen, and the text, the message to send or print, for example, hello world. We have get authorized user function so that only people you trust can use the print skill. It reads the allowed Telegram user IDs from environment and checks them against the sender's chat ID before printing. The environment file also specifies temporary folder for generating PDFs. So when a message is received from Telegram, a PDF is created with the content. It's sent to the printer. Then the file is automatically deleted in 10 seconds. Note that you don't need to run CLI.js yourself. The OpenClaw agent executes it automatically when it sees a trigger like print hello world in a message. When we run the application from Telegram and type print hello world, I get a response like I have printed hello world. However, in reality, the app hasn't been triggered yet. The agent can see the skill and it triggers, but it still has to decide which tool to use. Without an explicit rule, it often chooses the message tool and simply replies in chat instead of actually running the script. Since skill ID doesn't specify like use exec for this skill, the agent may respond with the message claiming it printed the content even though the script was never executed. In the workspace, we have an agent.md file. So the agent.md is the main rules file for the agent. It's loaded every session and defines how the agent behaves in this workspace. In this file, we added content regarding Telegram HV print, which instructs the agent to use the exec tool for the print commands instead of message tool. So these two variables, sender ID and X, come from the OpenClaw, come from how OpenClaw passes the message to the agent. They are derived from the message metadata. So sender ID is sender's Telegram's user ID. The agent received it in the message context and uses it as sender ID when building the command. And the next text to print. It comes from the message text itself. For example, if someone sends print hello world, the agent sees the full text, recognizes the print trigger, and takes everything after print as the text to print. So in short, the sender ID comes from the message metadata, and its X comes from the message text after the trigger. The agent's exec command then becomes a command line, and as args function reads chat ID and text from that. Telegram HTTP print long polling. So phone Telegram servers. The phone keeps persistent connection to Telegram. OpenClaw Telegram servers. OpenClaw uses long polling. So the request OpenClaw sends get updates to Telegram and waits. Response. When a user sends something, print X, Telegram returns the update, and the loop again. Then OpenClaw immediately sends another get updates request and waits again. So OpenClaw repeatedly calls get updates, waits for new messages, handles them, and then starts a new request. The connection stays open until Telegram has updates to send. Long polling is a simple way to receive updates without running a webhook server or keeping persistent WebSocket connection. It's well suited for bots that run on a single machine and can keep process running that continuously polls for updates. This is the skill flow diagram. So the user sends print text in Telegram. The OpenClaw agent received it and runs the exec tool. Exec tool runs CLI.js with chat ID and X. So run CLI.js loads environment file, Telegram authorized users and printer temp path, parses chat ID in text, checks authentication, chat ID in allowed list, if allowed, calls print.js. So print.js write PDF to file, creates temporary PDF, then send to printer, runs PowerShell, like start process file path verb print. So PowerShell sends the PDF to the default printer. We are going to test printing from the Telegram. Since I am showing phone mirroring while recording, my phone needs to be connected to the same Wi-Fi network. But I have tested the application by connecting Telegram via 3G, while the home network, notebook and printer are connected through Wi-Fi. Actually, you can test from downtown or from another country as long as your Telegram is connected to the internet, your home notebook is on, Windows is not sleeping, the gateway is running, and the printer is connected to the notebook and powered on. First, I have to run the command OpenClaw gateway run to start the gateway. I also open the C temp folder where Telegram print PDF should be generated before printing and then deleted. You should see it. To test printing, I type the following command in Telegram. Print. Today I will focus on one important thing. Normally the Wi-Fi printer is located in a nearby room. However, for testing purposes, I brought the printer next to me to demonstrate it, and it still maintained a Wi-Fi connection. As you can see, it's printing now. I will open the camera and I should see today I will focus on one important thing printed. Yeah, it was printed successfully. I already described how we should start printing in the previous case. Let's start the gateway. This time, instead of typing print followed by the text, I start with the slash command, like Telegram HP print. The Telegram bots can have slash commands registered by a bot fodder or the bot API, and the command's description comes directly from the skills.md file. You see, it says print text to default, and here in the MD file it's print text to default printer via Telegram. And type Telegram HP print the best time to plant the tree was 20 years ago. And it's printing now. Let's open the camera and see. It was printed successfully.